Hello everyone and welcome to my daily integral challenge. The purpose of this channel is just to solve some integrals and show you how it's done and maybe solve differential equations, or if you leave a comment and tell me a topic you want me to ramble about, please do so I have enough stuff I can talk about. Today we're going to look at the integral e to the x times cosine, the hyperbolic cosine function of 2x dx. And we're going to approach this in two different ways. First, I am going to solve this integral by partial integration, and after doing it via partial integration, I'm also going to do it by the identity of the hyperbolic cosine function. So, to make it a little harder on myself, and thus the name of the channel, I am going to set myself a time limit. I say 10 minutes for this integral to explain it and to solve it. Alright, let's get right into it. 3, 2, 1, go. Alright, if we solve this integral by partial integration, the first thing I'm going to do is I'm taking this first part here and I'm going to define it as a variable I. After this, the first thing I'm going to do is do the partial integration. E to the x does not do anything for me. I am not going to integrate that one. Instead, I'm going to focus on the hyperbolic cosine function. So the integral of the hyperbolic cosine function is just the hyperbolic sine function, but we have to apply the chain rule also. So the 2 must be a factor of a half. Let's pull it into the front. So we have 1 over 2 times the hyperbolic sine function. Whoa. Good start. Hyperbolic sine function of 2x times the other function, which is e to the x, minus the integral of our integrated part, which is 1 over 2 hyperbolic sine of 2x times differentiation of e to the x, which is just e to the x dx. Alright, so this doesn't bring us anywhere. So what we're going to do is we're going to do it again. Like, the first part doesn't change. We have 1 over 2 times the hyperbolic sine function of 2x times e to the x minus, and we have to open parentheses here, and the integral of the hyperbolic sine function is just the hyperbolic cosine function. But again, we need to apply the chain rule. So we have a half times a half, which is a quarter. So 1 over 4 times the hyperbolic cosine function of 2x times e to the x minus the integral of 1 over 4 times the hyperbolic cosine function of 2x times e to the x dx, and close the parentheses. So now we've come full circle. We're back at the beginning. We're back where we started. So now this I part comes in handy. But first let me do some things, like open these parentheses. Times e to the x minus 1 over 4 times the hyperbolic cosine function of 2x times e to the x, and now we have a plus 1 over 4 times the integral of the hyperbolic cosine function of 2x times e to the x dx. So what I can see now is that this part here, well, this is just our I again. So what I'm going to do is I'm going to subtract 1 over 4 I on both sides. So what I'm left with is 3 over 4 I, which is equal to this entire rest here. 1 over 2 times, and let me get that e to the x out, hyperbolic sine function of 2x minus 1/2 the hyperbolic cosine function of 2x. Alright, now we're almost done. The last thing we're going to do is to multiply by 4 over 3 on both sides, and we get I is equal to, what's it equal to? 2/3. 2/3 times e to the x of the hyperbolic sine of 2x minus 1/2 times the hyperbolic cosine of 2x. Close those parentheses. Alright, this is the first solution of this problem I'm presenting. The next solution is going to be a little bit different. Let me just draw a line here. Whoop! I am not good at drawing lines. Anyway, as you might know or might not know, the hyperbolic cosine function of x can be written to 1 over 2 times e to the negative x plus e to the x. Alright, if we have a constant factor in front of the x, the constant factor will just appear in the exponents of the exponential function. So in our case, this will be 2. So it will be 1 over 2 times e to the negative 2x plus e to the 2x, which means I can rewrite my integral e to the x times the hyperbolic cosine function of 2x, which is equal to, let me pull that 1/2 already into the front, e to the x times e to the negative 2x plus e to the 2x. Alright, and get that dx behind it. Good. So what we can do now is just add those exponents together. So I have 1 over 2 times the integral of e to the x minus 2x plus e to the x plus 2x dx. Oh god, running out of space. Good. Let's add those together properly. We get 1 over 2 times the integral of e to the negative x plus e to the 3x dx, which is equal to, now we can pull this integral apart and we get 1 over 2 times the integral of e to the negative x dx plus 1 over 2 times the integral of e to the 3x dx. Okay, and for the final step, let's just integrate it. The integral of e to the x, of course, is e to the x, and for e to the negative x, it's gonna be negative e to the negative x. Why? Because the chain rule. Alright, we have negative 1 over 2 times e to the negative x, and for 3 e to the 3x, that's going to be 1/3 e to the 3x. That's times a half, which is equal to 1/6. So we have plus 1 over 6 times e to the 3x. And those are two solutions for this integral. Somebody smarter than me can probably do the math up here. We can, well, let's see. Well, let me rewrite this a little bit. So we have 2/3 e to the x. What's the hyperbolic sine function? There's probably something about the hyperbolic sine function I've forgotten. I think it's just a minus between the two. See, I'm forgetting stuff all the time. So let's just assume it's 1/2 times e to the negative 2x minus e to the 2x minus 1/4 times, yeah, that's how we get to the 1/6 down there, times e to the negative 2x plus e to the 2x, etc., etc. And we will eventually end up down here again. Ooh, let's make this yellow. Oh, let's take this away. Alright. So, the video took a little longer than 10 minutes, however, I think I solved it both ways in 10 minutes. Alright. Thanks everybody for watching. If you have any interesting topics you want me to talk about, or any integral you want me to solve, just post it in the comments. If you don't have anything to tell me, I'm just gonna find an integral on my own and I'm gonna solve it tomorrow. Alright, thanks everybody for watching, and I'll see you next time.